Welcome back, final episode. Since our blower door test, we've completed the house and we've done our insulation, final layer, linings, paint, joinery, and now we've finished the final piece of the puzzle, and that is the mechanical ventilation system. So we know we've got a certain amount of cubic meters in the house now. We've had the blower door test, we got 0.2. So we have a very, very little amount of air leaking in this house. Passive house standard is 0.6, so the increase in performance is huge there. And now we can easily manage that air in this environment because it's so airtight. So the mechanical ventilation system can just work efficiently 24 hours a day in the background, just supplying and extracting that air, filtering it, supply, extract, and you just turn it on and let it do its job.
In a normal house with openable windows, as you open a window on one side and on the other side, and the air passes all the way through, and that's kind of what happens. So in a high performance house that's airtight, like a passive house, we have to do this mechanically. So we inject fresh air into bedrooms and into the living rooms. Effectively, that becomes a positive pressure zone, and that spills out into your hallways and it travels down into your wet rooms, which is your bathrooms, your laundry, your kitchen, and they are negative pressure zones. So we're drawing air out of those locations all of the time. So that's 24 hours a day, 7 days a week. Those areas become negative pressure, so any moisture in those locations is contained in those locations and also removed. So the ventilation unit will extract from your wet rooms, it'll bring all of that back to the unit, it'll recover or strip the heat out of that, it'll send the heat across to the incoming air supply, but the moisture just passes outside, it just disappears.
So I'm commissioning this MVHR unit. So right now I'm going around and measuring the air speeds. So I'm just getting an average reading, what's coming out of every single extract and intake. And a reading on the master bedroom over here. The master bedroom came through at 16 on my reading. And right here, according to Steve Eltron, we're looking to achieve 30. And then we'll carry this out across the whole house, getting the readings of what we have now, and then we will adjust each dropper to achieve the right reading. Right, 19.
If we look at all of the living spaces and the air volumes being injected into those spaces versus the wet rooms and all of the return air volumes added together, those two total bottom line values must be the same. And what that means is that we're not pressurizing the house and we're not depressurizing the house. But also what's happening with the heat exchanger core is that the same volume of air is passing through the heat exchanger core on both sides, and that gives us our maximum heat recovery efficiency. Doing higher levels of air tightness and higher levels of insulation, higher performance windows for that matter, those are pillars, and one of the pillars is also your heat recovery ventilation. So they all work together to get this high level of comfort that we're desiring. So you can do one thing or the other, but really what you need to do is do all of them together.
Thinking about the insulation being continuous and thermal bridge free from when we design it all the way through to when we complete the structure, and that goes the same for the air tightness, and that goes the same throughout the whole building process. So as you can see, if we don't do this correctly, that's not going to work as well. Or if we don't do the air tightness and vapor barrier correctly, Insulation over time will deteriorate, and if the home isn't airtight, then mechanical ventilation isn't going to work efficiently. So all of those 5 principles are all complementing each other. One's not working solely like on its own. So you can see this idea of continuity between the principles and Passive House Standard. It also applies in the planning and design phase with the relationships between each party. You've got your builder, you've got the owner, the architect. Those parties complement each other at the initial design phase. How is the design going to reach the standard or be energy efficient? How's it going to be built? How are we going to get the mechanical ventilation services throughout the home? Say, for example, here at Moonlight's a 2-story, and we've got to get all our ductwork into each room through a mid-floor, so that's where we use the Posi-Strut floor. So without the builder being on board early, the likelihood of reaching the standard is at risk, as well as, without a certified designer using PHPP, you're probably going to miss some of those key areas.
So a lot of people ask, why did you use Posi-Strut flooring, and why do we recommend it to clients? It is, known as a bit more of an expensive floor joist system. If you look up there and see what we've been able to achieve and how much easier our sub-trades job is with this flooring system, they're not drilling any holes, it's easy to run their cables, their pipes, and just knowing that I don't need to worry about my subs drilling holes anywhere, because there is endless opportunity for them to run all their services. The floor system, the supply of Posi-Strut might be a little bit more expensive, but your cost savings for your builder and project management is huge, because I'm not having to worry about where these ducts and plumbing and supplies and where our subs drill holes is going. I just know that they have the room to do it all. So the cost savings for me is in your builder's project management.
Having a builder involved in the process as early as possible is a really good thing from a cost perspective. The later in the process, in the design process, that you make changes, or even in the construction process, the more expensive it's going to be. So just naturally through administration costs and rework and things like that. So having a builder involved in the process early can identify details within the drawings where it might not be possible, like from a buildability perspective, and then also find efficiencies in designs for building. The upfront cost is very small to get a builder involved in a few design meetings, and it can have a big impact on, like a compounding effect on the price at the end of the job. So it's highly beneficial.
So you can see how continuity as an idea runs throughout building to the Passive House Standard from start to finish, just from planning to in the design to execution to completion. And then it continues on afterwards once you're living in the house, and you start to see how the home is working to its modelling. You're in winter, you're getting that low sun. You still have this home, we still have a heating demand of 21 kilowatt hours per square metre. So we still have some heating. And then you're seeing how that modelling works and how those windows bring in that low sun into the house and then warm up the space for a limited time in winter. But then, okay, so I need to time my heating to to cater for my heating demand in those shaded hours. And you just work out, slowly you work out the more efficient way to be living in the home. We've installed a solar system with a Tesla battery on the home.
So on this property we've got 14 Hyundai 390 watt panels. Obviously it's a really high performance home, and so we've looked at some of the modelling and we've created our own modelling about its energy demand. Typical home in New Zealand, or I suppose in Queenstown, we're installing probably slightly higher than that, kind of 18 to 24 panels with a battery setup. But in this situation, the demand in the property is quite low because it's so efficient. And so we've started off with a smaller array that we're confident will cover the demand and have ample access to charge that battery in the day. And so we model every home from plans, if we can get hold of them, especially with a new build. It's nice and simple, and that model takes into account the angle to north, pitch of the roof, weather data from the local area, and any shading from any trees, and we can create really accurate data of how many kilowatts the system will produce annually, on average per month, and average per day as well. And so it's really accurate. We're expecting this system to cover kind of 70+% of demand of the home, and so that's something around 6,000 to 8,000 kilowatt hours a year. Net result for the homeowner should be a dramatically reduced bill. I imagine their power bill will be something like 20 to 30% of what it would be without solar and a battery.
So here we have the connection to the Tesla gateway. It's showing us live data from the solar production, the loading in the house, and the state of charge of the Powerwall. This is showing right now that the solar is powering everything inside the house, and the excess is being directed into the Powerwall to charge it.
Yeah, on a sunny day we're producing, in winter, short days but sunny, we're producing 10 kilowatts, and the battery can store 13.5. So, you know, in winter we can charge that battery, use the solar to kind of take care of any of our small energy needs in the middle of the day. And then obviously at night, when everyone gets home, we use that battery. And then another thing we're actually incorporating is on our energy contract. We get free power for a time period, and we just put our heating on and charge our battery. And then, you know, being a passive house and being so airtight and energy efficient, that heat just doesn't evaporate once the heating's off. So yeah, it's a bit of a win-win at the moment.
So we've got a 24-hour period here, midnight to midnight. Above the line is demand, the battery discharging or solar production. We've got 3 colours: blue for the battery, yellow for the solar, and red for grid. In the early morning, the battery's discharging and meeting the demand of the household. Up until the grid's helped out a little bit, you can see this red spike here. The demand at that moment in time is higher than the battery can discharge, and so it's working in combination. At about 9 o'clock in the morning, the sun's come up, and the solar has had enough power to cover the loads in the home, and so it's reversed, and the battery here has started charging up again. In the later afternoon, once the battery's got up to 100%, because it's grid tied, solar then exports to the grid and you get paid a small amount from your energy retailer, a little bit of extra help to cover the return on investment. The reverse happens when the sun sets, battery's discharging again. A couple of little periods where the grid's helped out. Again, demand at that period of time has been a little bit higher than the peak output of the battery. And then at 9 o'clock here, time-based control has happened. And so the battery knows, right, I've got free power, I'll charge from the grid again, but I'll also cover the load in the home. So in a 24-hour period, we've taken a little bit of grid power here in the early morning, probably with breakfast, A little bit of grid power here, well, probably while having dinner, but in effect, off grid for 23 hours of the day, something like that, and with a cost to the client, probably net zero. A little bit of cost from drawing the grid here and here, but have exported some power here, so probably dollar value about a zero.
So far, I'm just stoked on the performance. It's better than I thought, and also I'm stoked on like what we achieved in the design and how we fell short of passive house, and we have a small heating demand in winter, but that's already very small, like $100 a month, including electric. It's a fully electric house, so, and that we have a very, very low 1% overheating in summer, so I'm looking forward to seeing how that goes. I'm just stoked on the comfort, the performance, the modelling is accurate, and yeah, like the numbers don't lie. So yeah, it's been pretty awesome to live in it and experience it. And it's freezing outside. You open that door and it's just like, and you just don't want to leave. From what we've learned is worth striving for that passive house principle and incorporating those 5 principles into your build. You don't necessarily have to achieve the standard, but using all of those 5 things and modeling your home is going to make a huge difference to your comfort, and a huge difference to the environment, and a huge difference to the longevity of the building. And if you're thinking of these things from the start, it's going to pay off in the comfort in the long run. So yeah, even if you don't get to the passive house standard, but you've worked to it, you're going to have a home, 5 times better than most in New Zealand.